Hello students, welcome to the Electrical Engineering YouTube channel. Today I am going to start a new lecture series on the subject of numerical methods. In this course, I will demonstrate you various numerical methods and numerical analysis tools to numerically solve complex engineering problems. These complex engineering problems include nonlinear equations, regression analysis, interpolation, numerical differentiation, and integration. The recommended books for this course are Numerical Analysis by Richard L. Burden. The second book is Numerical Methods with Applications by Autar K. Kau. The outline of the course is defined as the introduction to numerical analysis, solution of nonlinear equations, regression and interpolation, numerical differentiation and integration, initial value problem for ordinary differential equations, numerical optimization. Mathematical models are an integral part in solving engineering problems derived from engineering and science principles or experimental data. So in this first lecture, I will demonstrate the basic concepts of limit, continuity, differentiation, and some fundamental laws and theorems which will be used later in the course. So first thing is the limit. Limit is the value that a function approaches as the input approaches some value. Limits are essential to define continuity, derivatives, and integrals. So limit can be defined as the limit x approaches x naught f of x is equal to L, and L is the limiting value of this function f when x approaches x naught. So when x approaches x naught, f of x will be approximately equal to L, or f of x will approach L such that the error or the difference between f of x and L will be very, very much small. So the magnitude of the difference between f of x and L will be smaller than epsilon, and epsilon is called the error or the tolerance. So if we specify the tolerance to be 10 raised to power minus 6, then if f of x minus L becomes smaller than 10 raised to power minus 6, we will say that this value f of x will be equal to L. So whenever x belongs to x, so x is the set of points and this x is a single point, and when this x belongs to these set of points, the difference between x and x naught will be very, very much small. So the magnitude of the difference between x and x naught will be lying between 0 and this delta. So this epsilon is the difference between f of x and L. So these are the axes, these are the values along the y-axis, and this is the error, or these are the values along the x-axis. So you can see this is x naught, and this is x naught minus delta, this is x naught plus delta. So there will be some specific value of the tolerance for the x-axis and some specific value of the tolerance or the error for the y-axis. So next we will discuss the continuity, and the continuity can be defined as the function f is continuous on the set x if it is continuous at each number in x. So if we have a range from one point to the other and the function is said to be continuous between the within the range of x, such that f is defined at each point within the range of x. So if there is any single point at which the function value is undefined, then we will say that this function is not continuous. For example, if we have a tangent function and if we want to check the continuity between 60-degree and 120-degree, then the tangent function is a discontinuous function because it has an infinite value at theta equal to 90 degrees. So between 60-degree and 120-degree, this function has a discontinuity at theta equal to 90 degrees. So tangent function is a discontinuous function. So now we will discuss differentiation. So the definition of differentiation is written over here. So the derivative of a function at this point x naught is equal to limit x approaches x naught f of x minus f of x naught divided by x minus x naught. So the differentiation actually gives us the slope of a tangent which is drawn at specific point x naught over the function. So if we have such a function f of x, and if we want to take the derivative of this function at x naught, so we have to draw a tangent at this point x naught, and we will have to calculate the slope of this tangent. So that slope of this tangent will give us the derivative of this function at this point x naught. So the number f derivative x naught is called the derivative of f at x naught. The derivative of f at x naught is the slope of the tangent line to the graph. Next theorem is the Rolle's theorem. So suppose f belongs to this interval a and b, and f is a continuous function between uh, a and b, these 2 points, and f is differentiable on a and b. If f of a is equal to f of b, then a number c in ab exists with f derivative of c equal to 0. So suppose we have a function f of x, and this function is defined between these 2 points a and b. So there is definitely at least one point at which the derivative of that function is equal to 0. So in this case, we have two such points. So at this point, if we draw the tangent, so the slope of this tangent is equal to 0, and this is called the maxima. Similarly, if we draw a tangent at this point, the slope of that tangent will also be equal to 0, and this point is called minima. So here we have 2 points, but there will be at least one point at which the derivative of the function will be equal to 0. But the condition is that the value of the function at these two extreme points should be same. So this is f of a, this is f of b, and f of a is equal to f of b. If this is the case, then this Rolle's theorem states that there will be at least one point at which the derivative of this function is equal to 0. Next is the mean value theorem. So mean value theorem states that if f belongs to a continuous interval between a and b, f is a continuous function within this interval a to b, and f is differentiable on a and b, then a number c in ab exists with f derivative of c equal to fb minus fa divided by b minus a. Suppose this is a function and it is defined between the points a and b, and here you can see that this is the point a, this is the point b. If I draw a straight line from this point a to this point b, then the slope of the straight line is equal to fb minus fa divided by b minus a, because the definition of slope is equal to y2 minus y1 divided by x2 minus x1. Here we have y2 equal to yb, and y1 is equal to f of a, and y2 is equal to f of b. Similarly, x2 is b and x1 is a. So the slope of the straight line is equal to fb minus fa divided by b minus a, and the function, our function is actually this sinusoidal curve, and there will be at least one point at which, if we calculate the slope of the tangent, the that slope will be equal to the slope of the straight line. So here again we have two such points. So at this point, if we draw a tangent, that tangent will be parallel to the straight line, and the slope of this tangent will be equal to the slope of the straight line. So this condition will be satisfied. Similarly, if I draw a tangent at this point, then that tangent will also be parallel to the straight line, and the slope of that tangent will also be equal to the slope of the straight line. So at this point, the derivative of the function is equal to f derivative of c, and at this point also the derivative of the function will be equal to the derivative of a function at this point c, and that is equal to the slope of the straight line. So slope is equal to fb minus f divided by b minus a, and this is called mean value theorem. Now I will elaborate extreme value theorem, and extreme value theorem says that if f is a continuous function between these 2 points a and b, then c1 c2 will also belong to this interval a and b, such that if f of c1 is less than or equal to f of x, and it is less than or equal to fc2 for all x belongs to a and b. In addition, if f is differentiable on a and b, then the number c1 c2 occur either at the endpoints or where f derivative is equal to 0. So suppose we have this function f of x, and it is defined, and this is a continuous function between these 2 points a and b. Now suppose that the maxima of the function is lying at this point C2 and minima of the function is lying at point C1. Okay, so this is fc1 less than or equal to f of x less than or equal to fc2. It means the value of the function is lying within the range of fc1 and fc2. So fc1 is the minima, fc2 is the maxima. Now, if either these 2 points C1 and C2 are the extreme points of A and B. Otherwise, these 2 points will be local maxima or local minima. So this is called extreme value theorem. So in this case, we can see that these 2 points C1 and C2 are not the endpoints of this range A and B. So it means these 2 points will be the maxima and minima, and the derivative of the function at these 2 points will be equal to 0. Okay, so this is what this theorem states. And next is the intermediate value theorem, and it is also a very simple theorem, and it states that if f belongs to a continuous interval a and b, and k is any number between fa and fb, then there exists a number c in ab for which f of c is equal to k. Now, suppose the value of the function at point a is fa and the value of the function at b is f of b, and now I select a number k, and that number k is actually lying between fa and fb. It means there is definitely at least one point within this range a and b at which the value of the function is exactly equal to k. Okay, so this is called intermediate value theorem. And to elaborate more on the intermediate value theorem, I will solve this very simple example. And in this example, we are given a function f of x, which is x raised to power 5 minus 2x cube plus 3x square minus 1 equal to 0. And we have to show that the function has a solution in the interval from 0 to 1. So this is the function, and this function has to be equal to 0. The solution of the function is lying at the point at which the value of this function is equal to 0. So if I put a value of x equal to 0 in this function, then I will get an answer of -1. So this -1 is less than 0. Similarly, when I put the value of 1 in this function, I will get the answer of 1, and 1 is greater than 0. So clearly at one point my function is equal to 1 -1. At other point the value of the function is actually 1. So it means between this range 0 to 1, there is definitely one single point of f such that the value of the function is equal to 0. It means this function has a solution between these 2 points 0 and 1. So from the intermediate value theorem, we can conclude that this function has a solution within this range 0 and 1, because upon putting the value of 0 in this function, I get -1. When I put a value 1 in this function, I get +1. So it means between 0 and 1, there is definitely one single point at which the value of the function is equal to 0. So that is all about today's lecture. I hope you have enjoyed these fundamental and basic concepts of limit, continuity, differentiation, and some theorems. So for watching more similar videos, please stay tuned to this YouTube channel. Until the next lecture, it's goodbye.